This video we're going to be talking about parallel lines. We'll be talking about how parallel lines are used. We use them for alternate angles, corresponding angles, and co-interior angles. We'll also be talking about how two lines can be proven as parallel. So let's get into it. So when you get questions in which you have parallel lines, like we see over here, a couple of things are true for parallel lines. We understand that for parallel lines, that this angle we have over here, let's call it A, will be equal to that angle we have over there. And so would this angle over here be equal to that angle we have over there. We would also see that the angle we have over here will be equal to that angle over there. Finally, this angle over there would also be equal to that angle over there. When you have parallel lines, those angles would always be equal. And the reason for that is called corresponding angles. And we say corresponding angles are equal. We also have another scenario whereby we would say the angle we have here is equals to the angle we have here. So would the angle over here be equals to the angle we have over here. And the reason for this is alternate angles. Now with alternate angles, the angles are also equal. And finally, when you have parallel lines, we normally say the angle we have here and the angle we have here, they add up to 180 degrees. And the reason for that is co-interior angles, right? Because co-interior angles are supplementary. Now, all this are true whenever you're given a question that has parallel lines. Normally, we call this fun. The reason why we call that fun is because the corresponding kind of looks like an F. With the alternate angles, that is an N. We would say that these are alternate angles. And the final one is the U. This is your U here is for your co-interior. And that's where F, U, N comes from. Corresponding, co-interior, and alternate angles. Now, it's very important you know this when answering Euclidean questions. But now, what happens if you were not told that these lines are parallel? So let's say we call this line AB, and this one here, we call this line CD. And you are asked to prove that AB is parallel to CD. When lines are parallel, we know we could use corresponding, alternate, and co-interior. Now, the same thing would also apply for this. So we'll use other methods for us to prove that the angle we have here is equal to the angle we have here. So if you can prove that A is equals to B, we can give the reason as being corresponding angles. If you are able to prove that A is equals to C, we can say that the reason over that would be alternate angles. If you can prove that A plus D gives you 180, then you can give the reason as co-interior angles. So if you are able to show angle A and angle B are equal, angle A and angle C are equal, that angle A plus angle D is equals to 180, then it should also mean that the lines that you're trying to prove would be parallel. Let us try out an example to help you guys understand this a little bit better. So you have this question over here which says ABC is a common tangent. So you can see we have two circles over there connected, or we could say separated by a tangent. We were told to prove that DG is parallel to EF. So for us to prove that DG is parallel to EF, remember what we said, we need to look for alternate, corresponding, or co-interior. So we're going to try to prove that angle G is equals to angle F. So before I start writing anything, let's do everything on the circle and see if we can actually get our answers from this. If I say this here is x, the angle that this is a triangle and that's a tangent, this here would be tan-chord, meaning that this angle is equal to that angle. The next thing I also know is that CA and ED are intersecting lines, and intersecting lines normally produce vertically opposite angles, meaning that this is also x. And finally, since AC is also a tangent and it's tangent to this circle also, and that's a triangle with chords, we can also say tan-chord, making this x. Yeah, that's it. So we write the proofs. We are trying to prove that G is equals to F. Because if you are able to prove that angle G is equals to F, you definitely prove that this is parallel. The first thing I see over here is that G is equals to dBA, tan-chord. Then the next statement I also see is I see that dBA gives you CBE because that is vertically opposite. And the last statement is CBE is equals to angle F, which is another tan-chord. So therefore, we know that angle G will be equals to angle F. Now, because they are equal, we can literally now say that DG is parallel to EF. And the reason for this would be alternate angles. I hope this helps. So that is exactly how you use parallel lines. I hope all this explanation gave you a better understanding of how it works. Do check out the description for more videos like this. And the next video will be talking about how to prove a line is a tangent. And on your way out, please don't forget to like and subscribe. Thank you.